and worked with. Number 1, what do I got? What do I have? The square root of 32 would be, John? 4 root 2. Good. We are always looking for a perfect square if we can. Simplify the square root of 16 is 4 root 2. Excellent. Number 2. Go ahead, you. 4 root 5. If you remembered the square root of 16 times the square root of 5, 4 root 5, but you may not have and used 8 and 10. Remember, you want to always get down to prime factorizations where you can't go anymore. Okay, and since it's a square root, for every pair, 1 comes out. Whatever's not circled stays inside. We multiply together. Okay. Number 3, 1 over root 5. Can we have a radical in the denominator? No. What do we do to get rid of it? Phoebe? Perfect. Root 5 over 5. We cannot have a radical in the denominator. Multiply top and bottom, called rationalizing. Number 4, what can you do first? Brian? You could divide 6 by 3, 2 over root 7, and then it's very similar to number 3. Okay, then what do we do from here? No? Good, multiply top and bottom by root 7. Okay, 2 root 7 over 7. Some of you might not have done that, okay, but if you have 6 over 3 root 7, the only thing you should be multiplying by is root 7, okay, if you left it like this, and then just simplify at the end. That is okay, but the only thing you are moving is root 7, because there's no adding or subtracting in between, okay? All right, number 5, who remembers this equation? Okay, Campbell, what is it? Good. Pythagorean theorem. Okay. Find the missing side lengths. Okay. Find the missing side lengths of a right triangle. Okay. And you probably provided some example on the side, and a lot of you will have different examples. Okay. Again, what does c squared represent, or what does c represent, Brian? The hypotenuse. A and B are your side lengths. Okay. Now 6 through 9, looking at number 6, what do you have to do here? Sorry. Cross multiply. Good. All right. So we multiply 2 times x plus 1 equals 4 times x. Perfect. Then what do we do? What do we do here in order to solve? Andrew? Yep. 2x plus 2 equals 4x. You want to get your x's on one side. So you have 2 equals 2x. Divide by 2. X equals 1. Okay. How many of you remembered what to do in this section? Okay. If not, it's fine. Okay. All right. X equals 1 for number 6. Number 7, you will be doing the same thing, and also 8, 9, and 10. So we have 3 times 2x minus 1 equals 5x times 6. 6x minus 3 equals 30x. Negative 3 equals 24x. Divide by 24 and then reduce. X equals negative 1/8 when you reduce. Okay. What did you get for number 8? You? 68 over 5. How many of you did get that? Okay, not a lot. So Here we cross multiply. Again, 66 equals 5x minus 2. You add 2 to the other side, and then divide. You could leave this answer as is. You don't have to go any further. Okay, if you wrote it as a decimal, fine, but fraction is just fine. How about number 9? What did we get for a final answer? Go ahead, Laura. Careful. Careful, careful. You have the right numbers, just different order. Good. All right. So you have negative 16x equals 5. Divide by negative 16. X equals negative 5/16. Excellent. Good job, you guys. All right. And the last one, which we're going to be using a lot today, what does this help us find? Go ahead, Campbell. Good. Angles. Anything else? Yeah. Side lengths. Good. Using our trig ratios, right? Okay. Using our trig ratios. What does the S stand for? What is it? Sine. Good. What does the C stand for? Cosine. T. Tangent. Good. So that's what we're going to dive into today. And again, a lot of it's going to seem like a little bit of a review. However, you haven't seen it in a while. All right. So a lot of the things might be a little rusty to begin with, but by the end, you guys will be fine. Okay, with all of it. And we're going to end with special rates today. All right. So if you turn the page, all right. The word trigonometry means triangle measures. Okay, we're going to study the relationships among side and angles of triangles. All right. In general, altogether, there are 6 trig functions. However, with geometry and this class, we're only going to look at 3. Those of you continuing to pre-cal will then look at all 6. Okay. We are only focusing on our sine, cosine, and tangent. Oops. Okay, sine, cosine, and tangent. Those are the 3 we're going to still focus on and do a little bit more with. Okay, so we have our right triangle, excuse me, that we're going to find missing sides, missing angles using right triangle trig. All right, so just to recall, sine, what does O over H stand for? Go ahead, Andrew. Opposite over hypotenuse, good. What does A over H stand for? Grace? Good, adjacent over hypotenuse. And then we already know what O, opposite over adjacent. Okay? Right. And we just actually went through this. Above, sine is opposite over hypotenuse, adjacent, A over H. Okay, just again, a recall. Right? All right. So, in the next part, we're given a right triangle. However, we have our angles labeled A and B. Okay? We're first going to look at angle A. And we're going to find the sine, cosine, and tangent. Okay? So, but first, again, to recall, because people mix a few things up, if this is A, this side length is what? Opposite, adjacent, or hypotenuse? Opposite this side length. And here. Hypotenuse is always across from your 90. Okay? So, to find the sine of A, what is my exact value for this triangle? What is the sine of A? 4 over what? 5. Right? 4 over 5, opposite over hypotenuse. What is our cosine of A? Go ahead, Lil. 3 over 5 adjacent over hypotenuse. And what is our tangent of A? Go ahead, Bri. 4 over 3. Good. Okay. So now if I switched to angle B now, this side length becomes what? Opposite this side length. Adjacent. Is my hypotenuse still the same? Yep. Okay. So what is the sine of B now? 3 over 5. Good. What would be the cosine of B? 4 over 5. And the tangent of B? Go ahead, Andrew. 3 over 4. Good. Okay. Just be careful when you're doing those because it may seem very easy, which it is. However, a lot of the side lengths kind of get mistaken for others. Okay. So interpreting some directions here. All right. So we want to find exact values, just what we did above. However, they're giving you theta. Okay. Theta will be used a lot. Okay. This just means an angle measure. Okay, that we're looking at. It's unknown right now. Okay. Theta is our angle measure. You're going to see this a lot. So that symbol looks like a 0 with a line through it. So that's what it is. Right? We have theta. So now, going from theta here, what is the sine of theta? What is the sine of theta? Gavin. Good. 8 over 17. Excellent. The cosine of theta, Finn. Good. 15 over 17. Awesome. Good job. The tangent of theta, Emily. Good. 8 over 15. Good. And for now, since we are recalling, if you guys need to label, go ahead. If this is your angle, opposite, adjacent, always across from your 90 is your hypotenuse. Okay? Great. Let's try one more. What do you notice in example 2? What's different, Brian? There's a radical. Okay? So you guys are going to try example 2. All right? However, now we're looking from angle B. So if you need to label, go ahead. Remember, no radicals in the denominator. Go ahead. I'll give you a minute. All right. So for the sine of B, what did we get, Abigail? Excellent. 4 root 17 over 17. How many of you guys got that? Good. Okay. Cosine of B, Phoebe. Awesome. Root 17 over 17. How many of you guys got that one? Good. Josh, tangent of B. 4. Good. Awesome. All right. So again, given all three side lengths, to find our ratios or exact values, we use our trig ratios. Okay? Yep. Quickly. Yep. All right. So now, if we're given cosine of theta is 2/5, we're going to draw a picture, right, of a right triangle. And it doesn't matter where you put theta, okay, as long as your right triangle is where it is. So I'm going to put theta here, and the next one I'll put a theta in another direction. So say this is theta. All right, we're given cosine of 2/5. So cosine is what in terms of SOHCAHTOA? Yeah, Andrew. Okay, so cosine, remember, adjacent over hypotenuse. So, across from theta, this is our what? Opposite, right? This would be at the bottom, adjacent. So what value would that be? 2. Across from your 90 is your hypotenuse, which would be what value? 5. So if I'm missing a side length, what do I do to find that side length? Sam? Pythagorean theorem. So we have a squared plus b squared equals c squared. Remember, c is always your what? Hypotenuse. Good. So it doesn't matter for a or b. Okay. So right now we have a squared equals 21. How do we solve for a? What do? Sam? Square root. Typically, when we are solving, what must we include? Plus or minus. Here, we're just going to stick with the positive. Eventually, when we get to the circle, you will be including plus or minus. Okay? So, here, our missing side length is the square root of 21. Now, can we find sine and tangent? All right. What is the sine of theta? Rory. What was that? Sorry. Perfect. Root 21 over 5. What is the tangent, Grace? Sorry. Careful. Root 21 over 2. Good. Root 21 over 2. All right? Okay. Now we're going to draw another picture. However, I'm going to put theta in another spot. Okay, here's your right triangle. I'm going to put theta up here. Okay? So tangent is what according to SOHCAHTOA? Opposite over adjacent. Okay? So across from theta, what value am I going to see here? Campbell? 1. And then right next to theta, 2. What am I finding? Hypotenuse. Go ahead. Go find your hypotenuse. All right. What is our hypotenuse value? Lizzie? Root 5. Excellent. Good. How many of you did get root 5? Pretty simple. Good. All right. The sine of theta. Bianca? Good. Root 5 over 5. Excellent. Okay. Cosine of theta. Lindsay? Good. 2 root 5 over 5. Tangent, we already know because that was given. How many of you did get both of those correct? Awesome, you guys. All right. Any questions? All righty. So now we are missing a side length. However, we are given an angle. Okay. So we are given an angle of 42. Okay. The side lengths given to us are what? Opposite, adjacent, hypotenuse. What is given to us? Yeah, Laura. Hypotenuse is 1, and the x is going to represent what? Adjacent. Okay. So what trig function uses adjacent and hypotenuse? Josh? Cosine. So to set this up, we have the cosine of 42 equals our trig ratio, x over 18. Before we do anything, how do I go about solving for x? What would you do, Andrew? You would cross multiply. So we would have 18 cosine of 42 equals x. Okay? Are we okay? We need our calculators. So take those out. Okay. Before we begin anywhere, we have to make sure we're in degrees. Okay? So with your calculator, right next to the second key, you're going to click on mode. Most of you, if not everybody, has radian highlighted, correct? Okay? So you want to scroll down to where it's blinking radian. Press one over to the right to where it says degree, and then press enter. So now you went from radians to degrees. Degrees is where we want to be. Okay? Everyone okay? And then second mode to quit out of that screen. Right? So now we're just going to type in exactly what we did. 18 cosine is right below program of 42. Press enter. One around to the tenths. Okay? So the missing side length, 13.4. Okay? So the missing side length okay? So one thing to keep in mind, must be in degrees. If you were in radians, you would get a negative value. So that's when you know you're not correct. Okay? So 13.4 is your missing side length. All right? So if we go to the next one, you have 21. What's given to us? Adjacent and opposite. So, what trig function uses both of those? Tangent. Okay, so tangent of 21 equals 9 over x. How do we go about solving? Go ahead, Campbell. Perfect. Okay, so we cross multiply, and over 21 equals 9. Then divide. Okay, so this again is where we go in our calculator. We want to make sure we're in degrees, which we already are. 9 divided by tangent of 21. Okay. Good. How many of you guys are, yeah. Go to the mode key. Scroll down to the third one where it says radian or degree. Press the right arrow to degree, hit enter, and then you're in degrees. Okay? All right. So when you are finding a missing side length but given a degree, you use regular, sine, cosine, and tangent. Are we all good? We all remember a little bit about that? All right. So now what is next is we're given two side lengths. However, we need to find our missing angle. Okay? So we're giving two side lengths, but we need to find our missing angle. So we're going to be using the inverse sine, cosine, tangent. If you look at your calculators and you see sine, cosine, tangent, you will see in either blue or whatever color, green, that it has sine with a little -1. Okay, remember that notation from inverse notation. That's what we're using. So if this is theta, okay, what trig ratio would we use? We're given these two side lengths. What trig ratio would we use? Yeah. Tangent, because we have opposite and adjacent. So the inverse tan, 26 over 11. Okay. So again, in our calculator, second inverse tan, 26 divided by 11. And you're rounding to the nearest degree. So what should have got? Theta equals 67. Okay? Right. So if you look at number 2, theta's here. What trig function would you use? Go ahead, Laura. Sine, good. Inverse sine, 14. Right. What does theta equal? Josh? 61. Good. Excellent. All right. Good. All right. So you guys are going to try some. All right. All of number 3, I think it continues. Wait, does it? Did I give you yours? Okay. Just right now, I want you to complete 3A and B. Okay? Complete 3A and B. Okay? This was 23.4. All right. Looking at 3A. Tori, how do I set this up? Perfect. Good. Sine of 37 equals x over 10.3. Good. And we went around to the 10th spot. So Jackson, what do we got? 6.2. Awesome. Good. How many of you guys did get that? Perfect. Good. All right. B. Let's see. Charlotte, how do I set this up? For B. You're finding the angle. You have to find the angle. Be careful. Careful. Think of a different trig ratio. Here's the angle, right? Remember, across from your height, 90 degrees is your hypotenuse. Perfect. Good. Good job. 13. And we are rounding to the nearest degree. Who has that one? Go ahead, John. 17. Good. Awesome. All right. Good job, you guys. How many of you did get both? Be careful. Okay. Good, good, good. Questions? Yep. Should have got 17.1. Just double check 4 over 13. Okay. All right. We are going to stop right there. Okay. If anything is of importance, if we had to kind of pinpoint the level of importance, this is top notch. Okay. This is what we have to recall, what we have to remember, our special rights. All right. So we are starting with special rights. This is the last thing we are doing today in terms of remembering our special rights, finding different side lengths, so on and so forth. So we first have our 45, 45, 90, which most of you should recall. Okay, here's our 90-degree angle with 45, 45, 90. The side lengths are the same. Okay, your side lengths are the same. However, across from 90 is your side length times root 2. Okay, so 45, 45, 90 is x, x, x root 2. Okay, so keep that in mind. So side length, side length, side length times root 2. Okay, what tends to get a little tricky is our 30, 60, 90. Okay, across from 30 is called our shorter side length. Okay, our shorter side. which is our x, okay? Across from 60 is our longer side, but it's x times root 3, okay? And across from 90 is our hypotenuse, which is 2 times our smaller side length. So we have x root 3, and then 2x, okay? So sometimes as you're going through this, labeling might help, okay, in terms of remembering what is what for each, okay? So if we look at, we're going to start with 45, 45, 90 first, all right? We are given, okay, one side length of 9 centimeters. What would be the other side length? Yeah, Grace. 9 centimeters. Now, what would be the hypotenuse on a 45, 45, 90? Yeah. Careful. Yeah, Phoebe. 9 root 2. Okay? It's your side length times root 2. Okay? So now, if we look at B, we are given our hypotenuse. Now, for 45, 45, 90, our hypotenuse equals what? What's our measure? X or x root 2? X root 2. So some of you guys will pick out what this actually is. But if I had to solve algebraically to find x, what would I do here? Yeah. We have 5 root 2 equals x root 2. I want to get x by itself. Careful. Divide both sides by root 2. And what happens here? They cancel out. So my side length is what? 5 centimeters. Would this side length be the same? Yes. Okay, the reason I'm showing you that is because if you look at C, we are given our hypotenuse is 18. Okay, our hypotenuse is 18. Since we're dealing with 45, 45, 90, we need to find our side length. So we take 18 equals to x root 2. Since we need to solve for x, what do we have to do here? John? Good. Divide by root 2. Then I have 18 over root 2. Can I have, yeah, go ahead. Good. Multiply top and bottom by root 2. So I have 18 root 2 over 2. Keep going, John. To what? Good. And we could simplify to 9 root 2. So both side lengths are 9 root 2. Now, one thing that I've seen, it is okay to have a radical as your side length. Okay, I don't want you guys to get tripped up just because we have root 2 and just label this as 9 because that is incorrect. Okay, so it's okay to have a radical. Does that make sense? All right, try the next 3 on your own. Okay, let's go through these. All right, so for D, okay, what does N equal? What is N? See? 8. What does M equal? You? 8 root 2. Good. How many of you guys did get that? Perfect. All right. For E, what does V equal? Good. 9 root 2 over 2. What does U equal? Yeah, you. 9. How many of you guys got 9? 9 is correct because what is our side length? Yeah. 9 root 2 over 2, and I know I'm multiplying that by root 2, okay? What is root 2 times root 2? 2. What can I do with these 2's? Or 18 divided by 2 gives me 9. Good. Excellent. Okay, so if we're given 3 root 5 as our hypotenuse, x and y, are they going to be the same? Yes. What do we end up getting for our side lengths? Campbell? 3 root 10 over 2. How many of you did get that? Good. Okay. So we know this is equal to x root 2. Okay? We divide both sides by root 2. We cannot have a radical in the denominator, so again, we need to get rid of it. So we have 3 root 10 over 2, which is both sides. Okay? Questions about 45, 45, 90? How many of you are recalling and pulling that back? Kinda, sorta? All right. The next piece is our 30, 60, 90. Okay? So in A, what is given to us? The length of 30 degrees, 60, or 90? What is given? 30. So this is our shorter side length, which is equal to x. What would y equal? Andrew? 8 root 3, and they're giving us units, centimeters, okay? Because it's x times root 3. Then what is our hypotenuse? Go ahead, Abigail. 16 centimeters. Good. Excellent. Okay. Now with B, what is given to us? 30, 60, or 90? 60. Okay. Now across from 60 is 18. What is that equal to according to what I have here? X root 3, or 2x? X root 3. So you have 18 equals x root 3. How do I solve for x? Go ahead, Andrew. Yep. Yep. 18 over root 3. Go ahead. All right, so we have 18 root 3 over 3. What's my shorter side length? Okay. 6 root 3 is x, so therefore, what would y be? Go ahead, you. Excellent. 12 root 3. Because it's only your side length times 2, and only your whole numbers you can multiply. All right? Are we okay? I think so. All right, let's look at C. What's given to us? 30, 60, 90. 90, right? So 12 is given to us. Across from 90, is that x root 3, or 2x? 2x. So what does my shorter side length equal? What does x equal? Go ahead, John. 6. Good. And therefore, what would y equal? 6 root 3. Awesome. Good job. All right. How about D? What's given to us? 30, 60, 90. 60. Okay. What does x, our shorter side length, equal? Go ahead, Grace. 12. Good. What does our hypotenuse equal? Brian? What is it? 24. Good. It's 2 times your side length. Excellent. All right. I want you guys to try a few. All right. You're going to try E through H. Okay? E through H. And this is 9, just in case you can't see it. This is 9. Oops. All right. So E through H. All right, let's go through these. For E, let's see, Y, what do we get, Sam? 3 root 3. How many of you did get that? Okay, you set 9 because it's across from 60 equal to x root 3. So I'll write it right here. You divide both sides by root 3. You cannot have a radical in the denominator, so you multiply top and bottom, and then you reduce. Okay, what does x equal, our hypotenuse? Campbell? 6 root 3? Good. Awesome. Okay, 6 root 3 because it's 2 times your side length. All right, now we get to F. What does V, so the shorter side length, equal? Laurel? 29. Good. What does our hypotenuse equal? Brian? 58. Good. Awesome. How many of you did get that? Perfect. Okay, now G. I think that's 36. Okay. Across from 60, and sorry about this, is 36. So what is our shorter side length? These both are not here. Andrew, what do you have? 12 root 3. How many of you did get that? Good. You are correct. Okay. What is our hypotenuse, Gavin? 24 root 3. Awesome. Good. And last but not least, we have H. Okay, Finn, what is Y, which is the shorter side length? Okay. Emily. Okay. Abigail? For Y? Okay. Someone get something different? Brian? 33 over 2. Because this is across from 60 equals to x root 3, right? When you divide both sides by x root 3, or root 3, you're multiplying, so these guys cancel. So you're left with 33 over 2. Excellent. Good. And what is our hypotenuse? Go ahead, Brian, finish. 33. Good. Your hypotenuse is 33. Since you're multiplying by 2's, the 2's cancel out. Good. All right. Any questions? Right. A lot of this was a little bit of a recap. Okay. Finally getting to our special rates, and that's what your practice is going to be on everything of 6.1. So the first stuff we did, ending with special